Hello, Khalil here. I'm going to do a quick little test. Hopefully I keep this video within a couple minutes. Alright, so I've actually already done this test a couple times, so I'm just going to fill these things out. These are all fine. So here is a test for using USB-C. We're going to drive this thing up to around 5 amps, see how it is, 6 amps, then 10 amps, and see what we have for voltage drop on the power supply. Here, if you kind of notice, we have a U-green USB-C cable. Link will be in the description. And we also have this little USB-C extension. This will be used for basically a connection from within a, this will be basically a connection from one window to another window. It's not too important what this connection is meant for, but I just want to see what happens when you have an extension cable here. Okay. What we have here, if you can see this, is a, let me focus on that. We have a USB-C breakout board. I have each one of the Vbus and ground connections shorted to each other so that when we power this thing and supply current from the power and the ground, it just goes straight from one end all the way over to the other end. No issues there. And then we have a couple of cables connected here. Just do a couple of them. I was curious if there'd be any difference. I found that there wasn't. And yeah, so without any further ado, put on my glasses here. I also have a FLIR camera that I'll use to detect temperature differences. Or detect the temperature. All right, so, and lastly, just so it's all kind of known what the application is for why we're driving up to 10 amps or even more into this thing. The game plan is to use it for this motor here, is the RMDX7. It is a smart servo. It uses CAN bus and operates at 24 volts and can draw up to 6 amps. 10 amps is just really to push it as far as we can go to see how big of a voltage drop we can expect, and also how much current can we put through these things for how long before it starts to become a problem. All right, so without further ado, let's start moving this guy up. So first things first, we're going to drive this guy up to 5 amps. And I expect this thing to just be nice and fine. It might get a little toasty, but I don't think it'll get too crazy. Okay, so around about 5 amps, good enough for me. We can see that there's a voltage drop of 0.88 volts, which is that number up here. It should be focused in properly. Yeah, you can see it. Okay, let's use the thermal camera to see if I can take a look at some things. So here, let me zoom in on, let me focus in on that. Come on now. Cool. All right, so we're going to focus in there, and you can see that the connector, the part that gets the warmest is actually this area of the connector here. I think it's just a part of it that's actually meant to dissipate power, which is fantastic. You see here that it's around 23 Celsius. If you look at like the actual like table, which should be at ambient, we see it's around 19.2 Celsius. And if we go over here, I hope we can still see that. Let's move a little bit, let's tilt a little bit. Cool, so here, you can actually see that the temperature is around same, not too much different. You can actually see the PCB layers on the inside. You can see that the power and ground layers are actually one big layer. This is probably a 4-layer board, and they put power and ground on a couple of the layers. You can see it by just the thermal pattern here. And if you actually look at the cable itself, you can see that the cable is around about 25C. And I've checked other areas here, and not much else different there. I will check the, let me see if I can rotate this a little bit more, so I can get that on the camera. Yeah, so here's that junction with between the two USB-C, between the extension cable and the USB-C, and you can see that it's around 30. It's a little warmer than everything else, but it's not too bad. All right, so let's bump this up a little bit further. Go up to 6 amps, just so we can see the voltage. I'm not going to stay there just because like there's not really much to see here. It's up another 0.2 volts. Technically, we can calculate what the total resistance would be for these cables. You can do the math yourself. Let's bump this guy up all the way. All the way up. There we go. 10.25. We can see we have a voltage drop of around 1.78. And now we can see this thing sizzle. Now, it won't smoke up, unfortunately. Actually, fortunately, because I really want to use this. Come on, you. There we go. So here, taking a look here, and we're getting around 40 degrees C. Oh, so that's also 50 or 48. Yep, seeing 51. Okay, so it's getting kind of toasty. And you look over here, you can see that the connector is getting pretty toasty here. And the PCB is getting pretty hot. If you look over here at the cable's still a decent 30-something degrees. It's not getting too, it's not getting too hot. If you actually look over here at the junction between If we move over here a bit, let's focus on there. If you look at this area here, you'll see that this is actually going to get pretty warm, if I can actually feel it. Wow, that's actually not hot at all. Is any of this hot? Not really. I thought it was warmer. It will get warmer though. I did this test before and it does get pretty warm. I think it got up to like 60, maybe 70 degrees C. It takes some time though. So from here, I'm just gonna kind of wait a little bit. The video's already at 2.5 minutes. Let's give it more time. This thing should heat up decently well, but it does take some time to actually, let's see. Yeah, here we go. Let's focus in on this. And this one's getting around about 60 degrees C. It's getting pretty toasty. The PCB, similar. Yep, it's getting around 83. Mostly the PCB is getting hot. Here we can see this thing's getting pretty toasty as well. And actually, this should be pretty hot to the touch. Yeah, that's pretty toasty. This guy, it's warm. Not that hot, though. But yeah, the U-greens, I think they might be doing a pretty decent job of dissipating the heat coming from here. Let's see what this one's doing. 50? Not too bad. Not too bad. Not bad at all. This one, though, why are you getting so hot? Unsure why you're getting so hot. It's not even that hot, actually, right now. What's getting the hottest? It's that junction. It's like right around here. Those traces there for like the shield and stuff like that are getting pretty warm. But for the most part, for our use cases, if this thing's running at 24 volts and we see a voltage drop of around 2 volts, that's not really a big issue. And as we can tell, the actual cables can handle this current for quite a sustained amount of time. It is quite chill in here, but even at the higher temperatures that we expect in the places we'll be operating this motor, I don't really see this being an issue. So I think 10 amps operating, let's bring this guy back into focus. Sorry about that. I think 10 amps operating should be more than enough, or should be, I think it won't ever be at 10 amps. This guy can only go up to 6, so I think operating this thing at 10 amps and verifying and showing that it can work properly at 10 amps and not cause any issues, yeah, I think this is fine. So yeah, that's pretty much it for this video. Nothing too crazy here, literally just passing current through a USB-C cable. And kind of showing that it's not that big of a deal to pass current above the 20 volts and the above the 5 amp rating, which is where most of these USB PD, USB 2.0 PD cables usually are around. Oh, and yeah, that's pretty much it. All right, see ya.